Hello everyone, Jai Hind to all. In this video lecture, I am going to discuss about the merge sort. This is the topic which cover inside the data structure, and the topic is according to AKTU, the topic comes under the unit 3. First of all, I am going to discuss about what we mean by the merge sort. Merge sort is an algorithm which is used to sort the given data in ascending or descending order, which may depend on question which type of sorting the question is want. It may be want in ascending or it may be want in a descending order. By using this algorithm, we can sort in the given form of the data, which may be ascending or descending. The merge sort algorithm is a sorting algorithm that is based on divide and conquer approach. Divide and conquer approach means we have to divide the given data in subset, then we have to sort the given data. After that, we have to combine and we find the final solution by using this algorithm. In this algorithm, the array is initially divided into two parts. Means the whole array is divided into two subparts. After that, we have to divide subparts into next subpart and sort the given data. After that, the sorting, we have to combine the given data in a single array. Then we are combined in sorted manner. There are three parts in the merge sort. The first one is divide. Divide means we have to divide the given data or given problem in subgroup and sort the given subgroup in a ascending or descending order, breaking the problem into subproblems. The second step is conquer. Conquer means we have to recursively solving the subproblems. That means after dividing the whole program or whole data in a sub data, we have to sort by using conquer approach the given data recursively. After that, the third step is combine. In this step, we have to combine the given sorted data to form a array, and which array is the form of ascending or descending order. This combining technique is used to sort the given data by combining the solution to get the final result. Now, the next point is algorithm. In algorithm, we have to give the list of steps which is used to solve the given problem by using merge sort algorithm. In step 1, we have to find the middle index of the array to divide it into two halves. Means we have to count or sequence the number of elements in the given array, and the given array is divided into two parts. The first part is first half and second part is second half. After dividing the whole array in two parts, we use step 2 that call merge. Merge is a function which is called to sort the given divided data into different parts. The third step is sort for first half by using merge sort array L and M. L is the lower bound and M is the upper bound of the array. By using this call, we have to sort first half and same we have to sort the second half. This step is used to sort the second half of the data by using array M plus 1 and R. Here L is the lower bound, M is the mid element, and M plus 1 is the just next of the mid element, and R is the upper bound of the given data. The next step is recursively merge the two halves in a sorted manner so that only one sorted array is left. After sorting the two different divided array, and we have to combine the two divided array in a single array, which is the result of our given array. This is a flow chart which is used to show how the problem is divided into subproblem or how the problem is grouped into different parts. First, we have to given problem. Problem means we have to given data on which we have to apply merge sort algorithm and sort the given data by using merge sort algorithm. First, we have to divide problem into two subproblems. The first subproblem is this one and second subproblem is this one. This means we have to divide whole data in two parts. The first one is the first half and second is the second half. By dividing this whole problem into subpart, we have to use algo to solve the first sub-problem by using solution to sub-problem. By using this step, we have to solve this first sub-problem. After that, we have same procedure apply on the second half, and we have to solve the given question according to the next first step. And after that, we have to combine these two steps to generate the solution of the problem. This is the main steps which is used in merge sort. As we discussed in previous algo, the whole problem is divided into two parts, sub problem. After solving the sub problem, we have to combine and generate the final solution of the given data. Now, this is the working of merge sort algorithm. In working of merge sort algorithm, this is a given data in which the data are 12, 31, 25, 8, 32, 17, 40 and 42. These are the given numbers, and we want to sort this given number into ascending order. This algorithm is to sort ascending or descending order, but in this question, we are considered to sort, we are taken to sort the given data in a ascending order. First, we have to divide this array into two parts. By these points, we have to take 12, 31, 25 and 8 as the first array, and second one is 32, 17, 40 and 42. This is the part of second array. After executing this step, we have also divided this array into two sub array, and the first array is 12, 31, second one is 25 and 8. And so, we have to also divide the second array 32, 17, 40 and 42. By dividing this algorithm, by dividing this data, now we also divide 12 and 30, 12 and 31, 25 and 8, 25 and 8, here 32 and 17, here 40 and 42. After this step, we are going to sort by combining these data. First, we have to compare these two data. If we want to sort the given data in ascending order, then we have to compare 12 with 31. 12 is less than 31, there is no swapping. 25 and 8, compare 25 and 8, 25 is greater than 8, we have to swap 25 with 8. Then again to 32 and 17 compare with each other, 32 is less than 17, so we have to swap 17 with 32. Here also 40 and 42, there is no swapping because 40 is less than 42. After swapping this different data, now we have to combine these. Here, after checking in ascending order, 12 is less than 31, so there is no swapping, and we have to combine and form 12 and 31. Here, 25 and 8, we have to swap 25 and 8. After swapping, we have to combine these two and form 8 and 25. Here, 32 and 17, 32 compare with 17, and 32 is greater than 17, so that we have to swap 32 with 17, and we have to write like this, 17, after that 32. Here 40 and 42, 40 is less than 42, so there is no swapping, and we have to write 40 and 42. After sorting these two, now we have to form the group of 4 elements. This group and this group. We have to compare each element and arrange in a ascending order. In 4 elements, 8 is the smallest element, so we have to write 8, then 12, then 25, then 31. This is the first group after combining the 12, 31 and 8, 25. In similar way, we have to combine this two array and sort in an ascending order. In this two group, 17 is the smallest, then 32, then 40, then 42. After sorting this, now again we have to combine these two array in a single form and in a ascending order. After combining, we have to sort the all elements. The smallest element is 8, then 12, then 17, then 25, then 31, 32, 40 and 42. This is our final answer, which is in a sorted form. In previous step, this one is called divide. because we have to divide whole array in a subpart. In next, we have to merge the divided array in a single array. So this step is called merge. And in merge step, a step is also executed. That step is called concur, because in case of merge, we first sort two element, then we have to merge that sorted two element in a single array. And by this process, we have to solve the given array in a ascending order. And this is the procedure which is used to sort the given element in a ascending order. The next point is complexity. Complexity means how much time or how much step is required to solve the given problem inside a main memory. Here, there are two types of complexity. The first one is time complexity and second one is space complexity. Here we have discussed about time complexity. In next slide, we have to discuss about space complexity. First, we want to show some technical points on which points the time complexity is depend. Time complexity depends on number of lines, how much lines inside the code, how many times your program is executed. That is depend on time complexity. And second one is space complexity. Space complexity is depend on number of variable, how many variables you are using inside the program. That is the main factor which affect the space complexity. But time complexity only depend on number of lines or number of instruction. There are three types of time complexity. The first one is best case, which gives near about the exact time of execution. Second one is average case, which gives plus minus the near about time of the execution time. And this is the worst case. This gives the maximum time taken by the program to execute inside the main memory. In merge sort, there is a basic advantage. In each case, which may be best case, which may be average case, or which may be worst case, the time complexity is order of n log n. This is the main advantage of merge sort, so that in maximum case we have to using merge sort. In best case n log n, in average case also n log n, and in worst case the time complexity is also n log n. This is the main basic complexity of the merge sort algorithm. The next one is space complexity. As we discussed in previous slides, the complexity is two types. The first one is time complexity, which depends on number of instruction, and second one is space complexity, which depends on the number of variable. Here, space complexity of merge sort algorithm is order of n log n. This is the main complexity, which is the depends on number of variable. Now, the next is program. How the logic is implemented to execute the given code by using the compiler. Here we have to discuss some main points of merge sort. This is the initial declaration of the function, where we have to use void merge int a type of array, int beginning, that is the variable which is hold the initial value or starting value of array. This is a variable which is used for mid value, and this is a end variable which is store the last index of array. Here the initialization of the all variable I, j and k. After that we have take two variable n1 and n2. n1 contain mid minus big plus 1 and n2 contain end minus mid. By using these two variable, we have to find the initial data, for which we have to compare and find out the element to be less than or greater than. After that, we have to swap accordingly. Here, we have also used two array. The first one is left array n1 and second one is a right array n2. This is the temporary array which is used to sort the given data in a ascending order or descending order. Here we have to copy the data in a temporary array, and we execute a loop for I equal to 0, I less than n1 and I plus plus. Here the left array is contain a beginning plus I, and the next loop executing on the value of j, and it contain the right array, and this indexing for this array is a mid plus 1 plus j. By using this statement, we have to swap or divide whole array in two parts by using temporary array. Here some initialization of the variable I initialize with j, I initialize with 0, j initialize with 0, and k is initialized with beginning. Beginning is the first index of the array. Now we have to use a while loop to execute or sort the given data in ascending order. While contain the condition I less than n and j is less than n2. Here we have to compare two temporary array by using if condition, and now we have to store the value of left array in a ak, and this is used for increment the value of I. In this is the else condition of if statement. If is false, then else to be executed. That means if the value stored at any index is less than the value compared, then at that condition we have not changed the value of or not swapped the value of the given array, and this is the else condition where we have to check the value of the given array. This is the last loop which is used to check the value of n1 and n2 with I and j. In first while we have to compare with I compare with n1, and the value is stored inside the left array, and here we have to check j with n2 and the value of right array with k index. By using these two loops, we have to compare the given value and store the whole data inside the given array ak. This is our final array which is want to print in the output function. This is the function which is used to sort the given data, void merge sort int a, int beginning and int end. This is the main if condition which is used to compare with beginning with end. This is the main condition which is used to check each beginning is less than end. If this is the true, we have to execute the given for statement, otherwise we pass this array and we have to go on next step. Here we have to find out the mid value, int mid equal to beginning plus end divided by 2, and here we call a function that is merge sort. Here a second function we have to call for second part. This is the first mid, and this is the next part merge sort a mid plus 1 and end, and this is the main merge sort algorithm which is called inside this merge sort algorithm. And this is the main part of to print the given data. That means after sorting the whole data, we have to print the final result by using this array. Void print array int a, int n, int I we have declared a variable I, and we have used a loop for I equal to 0, I less than n, I plus plus, and print percentile d ai. After that we have to exit this program and we get output by using this main technology. And this is the main function of this merge sort. Here we have take 1, 2, 3, 4, 5, 6, 7, 8. 8 value we have to take in here, 12, 31, 25, 8, 32, 17 and 40 and 42. This is the given data in which we have to insert inside the array, and this data is also shown inside the algo, how this data is sort. This is used for check bound of array, and by using this function we have to check if any error, or we have to not insert the given data out of the array. This is the printf function which is used to print the given data before the sorting. Before sorting we want to show which element we have to insert it inside the array by using this line. and this is the print array. This is used to print. This is the merge sort that which show inside the function how the merge sort function is called. After that, after sorting this by using this function, we have to call printf function again, and this printf function print the final result after the sorting. And this is the print array which is used to call for the function. This one is the print function which is used to call the given array, and this is our final code, and this is the return function. Because we have using int inside along with main, so that we have to using here a return function. If you use main void main, then there is no need of int function. This is all about the program. Now, complexity. This point is discussed previously. Okay, complexity means how much time or how much memory is required to run a program inside the main memory. And there are two types of complexity. The first one is time complexity, and second one is space complexity. Time complexity divided into two parts. Time complexity divided into three parts: best case complexity, average case complexity, and worst case complexity, which is discussed in previous in merge sort algorithm. In all three cases, the complexity should be same, order of n log n. This is all about the merge sort. If any doubts or any question, you comment in the comment box. Thank you.